Okay, so in this video I am going to explain some important theorems of primal dual relationship based, because primal dual relationship I already have explained in 4 different videos, 4 different parts, and from if you come to see from part 1 to part 4, you will find there are some different types of questions, and if you are confident over these types of questions, then none of the questions is there other than these types of question to change from primal to dual. So just go, if you have not visited these 4 part of primal dual relationship videos, so just go to visit and you will be confident over the primal dual relationship types of the questions, so you can convert from primal to dual. So here I have taken some theorems, and I am going to prove this theorem by taking some examples, basic examples. So what is the weak duality theorem? Very important theorems. Already have applied this concept and have got the solutions from primal to dual, but there we didn't realize. If you come to see these theorems, now you will realize, now already have applied this concept and you have got the solution. Now in weak duality theorem, generally we can say for a maximization primal, just I am going to take the examples as a maximization primal. We can take minimization primal also, one of the examples, but the concept will get reversed. So if you are going to take the examples for a maximization primal, every feasible solution to the dual has objective functions values greater than or equal to every feasible solution to the primal. Very important theorem, just to go to read out. For a maximization primal, every feasible solution to the dual has objective function values greater than or equal to every feasible solution to the primal. So these theorems can be proved by taking these types of example. So you can take one example. So just I have taken one example, very basic examples, and these examples already have used for the different types of the question to change from primal to dual and for the different applications. But here you can see I have taken these examples, maximization types of objective functions, 3x1 plus 4x2, and subject to x1 plus 2x2 less than equal to 4, 3x1 plus 2x2 less than equal to 6, and x1 x2 are greater than equal to 0. So if you are going to find its feasible solution, so we already have seen through the graphical method and through different methods, simplex method and algebraic method, whatever method we already have applied, and we have got the feasible solution, and we know the procedure how to find the feasible solution. So if you are having 2 variables equations, so it's better to go for the graphical method, that is easy. So now just I have taken examples. If you are going to solve by using graphical method, either method, then you will get some feasible solution. So for these types of question, there are some I have taken some feasible solution, because feasible solutions we cannot say these are the solutions, only a feasible solution, because feasible solutions are unlimited infinite numbers of solution we can say, and there are the infeasible feasible solution under of these particular questions. So, but basic feasible solution, there are some certain numbers of the question solution that we call as a basic feasible solution. It means at the corner point only, whatever solution we are going to get, that solution generally considered as a basic feasible solution. But feasible solution may be infinite number of. Out of these feasible, just we have got some examples. If we are going to check this objective function with 0 0 condition, then you can find that the result will be 0. If you are going to check at 1 0, so 1 0 3 into 1 1 and 0, so you will get 3. That is the result, and all these values are going to satisfy the condition of the constraints. So parallel you may check all these values are going to satisfy the conditions of the constraints, as well as you are going to get some feasible solution. So here just I am moving in some certain order. We can say for getting the better feasible solution. Better feasible solution means it is the maximization types of problem. So at which corner points we are going to get the maximum values, that is the better solution we can say. So now we are going to move in this certain order, better feasible solution, and where we are going to get the maximum results, that particular corner points is going to be considered as a feasible corner points, optimal corner points, and we can get the optimal solution at that particular corner point. So this is the procedure to move. And if you are going to find the dual of this given primal, so dual of this given primal we can write like this. You know already the procedure to change from right hand side of the constraint to its objective functions, and the coefficient of objective function will come to the right hand side of the constraint. All the procedure whatever I have applied to change from primal to dual already you know, and already have explained in my basic part 1, means there you can move and you can see all these concepts. So I am not going to explain the basic ideas, just I am going to explain what is its primal and what its dual. So primal and dual, we have got its dual, and if you are going to find the basic feasible solution in this respects, in its dual. So if you are going to find the basic feasible solution in this respect, it means if you are going to put 0 0, y1 and y2, if you are going to consider as a 0 0, it means these terms will be 0 and 0 cannot be greater than equal to 3. So this condition is going to fail at 0, because if you are going to change from primal to dual, means you cannot say 0 0, that is the origin is applicable for both the primal and dual. No, if it is feasible for the primal, then for the dual it is not going to give you the feasible result. So here just have taken some points. Some points means we can say just 2 3 I have considered. These 2 3 is going to fulfill the criteria of constants as well as the objective functions criteria. We can get the different values, like for by taking the 2 3's y1 2 and y3 y2 as a 3, so we can get these types of results. So at different points we have taken different values, 2 3 3 2 1 1 3 by 2 1 by 2, and we realized if we move in this certain order at some particular points we can get some solution. So these solutions is called, from the dual also we can get the solution. So this solutions is called the optimal solution. Why we are going to consider this optimal solution? Because after this we cannot go for the certain, because from the dual we need to find the minimum values of the z. So here 9 is the minimum values of the z, and through the maximization 9 is the maximization values of the z. So if you are going to check these two, generally we consider the optimal solution. So through, if you are going to see the definition, you can ensure how to prove these theorems by taking this example. For a maximization problem, now I have taken the maximization problem. Every feasible solution to the dual. So every feasible solution to the dual. Now every feasible solution to the dual. Now this is the solution 26, 24, 10 up to 9. Every feasible solution to the dual has an objective function value greater than or equal to the every feasible solution to the primal. Just you check here. 26 is a greater than to all this value. 24 is greater than to all this value. 10 is greater than to all this value. 9 is equal to this particular values. So in the definition there are two important points. For a maximization primal, every feasible solution to the dual, just have taken examples, has the objective function value greater than, objective function values has a greater than or equal to every feasible solution. So equal to means wherever you are going to find the equal, that will give the feasible solution. Means we cannot say now we can go ahead and we can say no, this is the 9 and here we are going to get 10. So it is not possible to get the 10 values by applying the dual of given this dual LPPs, whatever I have converted from primal to dual. So wherever you are going to get, either the feasible solutions of dual will be greater or equal. We cannot say it's a less. So it cannot be less, we cannot say the feasible solutions of primal is going to exceed the feasible solutions of dual. No, always the feasible solutions of dual will be greater than or equal to its primal, and wherever we will get the equal values, that is the optimal solution. Now this is the first theorem is going to give you, that is called weak duality theorem. Second, I am going to take the optimality theorem. Optimality theorem is also, if you are going to see, that will give you the ideas of the weak feasibility theorem, because it is also going to say the same thing but with some different point of view. If the primal and dual have feasible solution, primal have a feasible solution, dual have a feasible solution. If means so here for this question, primal and dual both have a feasible solution with the same value of the objective function. So where we are going to get the same value of the objective function? Now we are going to get the same values, means 9 as an objective function. Then both are optimal to the primal and dual respectively. So here we can say this is the optimal solutions, and primal and dual respectively both are the optimal. So these values only we can consider as an optimal values. So this just if you are going to see these weak duality theorems and optimality theorems, they are going to say at most all words is going to be common. So these theorems almost are at the same theorem. So main duality theorems, what these theorems is going to say, means these main duality theorems is also going to say some points from these two types of the concepts. If the primal and dual have feasible solution, then both have optimal solution. If primal and dual have a feasible solution, then both have a optimal solution. The same optimality theorems is going to ensure. So main duality theorems is also going to ensure the concepts of optimality theorem. Optimality theorems is going to ensure the concept of weak duality theorems. Means all these theorems are having some relation in between their concepts. So if primal and dual have a feasible solution, then both have the optimal solution, with the same value of the objective function, for the 9. So now this is if we are going to take the examples if the primal have a maximization types of the problem, so if it is unbounded, the dual is infeasible. So it is very important, if the questions are given into the form of unbounded, so you can check. It means either it is feasible or not. So first you need to go through the graphical method. If you have given two variables question, then just go to check through the graphical method. If you are going to check, if you are going to find the solutions, if the primal is unbounded, then directly you can say its dual will be infeasible. Directly you can say its dual will be infeasible. But vice versa is not correct. You cannot say if the primal is infeasible, then the dual is unbounded. No, here you cannot say, because if the primal is infeasible, then dual is either unbounded or infeasible. So here there is a condition. If you take some these types of examples, if you are going to try, then you will find this particular theorems is going to exist. So you may take any examples that the result is going to give your unbounded, then you will get its solution, its dual will be infeasible. And if you are going to take some problems of that result is going to give you infeasible, and if you are going to find its dual, so dual might be infeasible, dual might be unbounded or maybe infeasible. So infeasible primal duals might be infeasible, infeasible dual might be unbounded. So maybe this condition exists with the main duality theorems. And fundamental theorems of the linear programming, same concepts also here going to explain. So all these theorems are having their some certain relations. If you are going to read out the fundamental theorem of linear programming, every linear programming problem is either feasible, unbounded or infeasible. Either infeasible, bounded, or either feasible, infeasible or unbounded. So these three types of result you may get. There is no other results out of these three types of the results for any LPP. If it has a feasible solution, then it has a basic feasible solution. If it has an optimal solution, at least one corner points will be the optimal. So it's ensured, because it's means if they are having, if their feasible solution exists, it means there exists a basic feasible solution. If a basic feasible solution exists, it means there exists an optimal solution. So if you go back in this order, because from fundamental theorem to main duality theorem to optimality, then weak duality theorems, you will find all these theorems are going to ensure the same thing. Same concepts is going to ensure, but the way of the speaking, way of the means way of the explanation, you can say, way of the telling and way of the explanation, whatever you are going to consider, just they are going to explain the same thing in different way. Different way means just I am going to repeat once and in fast manner, then you will get means the concept, and I will stop this particular sessions and will move into the next lectures, next video. So here just to go through the weak duality theorem, so you will find means the concept, and just to go for the optimality, and you will realize all the concepts are going to ensure the same types of concepts. So okay, so just go through with all this detail and try to see these concepts through some books. Hillier is the one of the means standard books, you can say. So I always suggest to every students to go for the Hillier books. There you will find means some standard types of questions, and all the concepts whatever have written there, it's means very means you can say it's a standard concept, standard words have written there, and all the technical words have mentioned. And once if you go through with those details, then you will be confident over the different types of question. So it's better to move to Hillier books and see some different types of questions for particular these types of the theorem, and try to prove those types of question by applying these theorems. So you will be ensure how to prove and how to solve these types of question by applying different theorems. Okay, so I think you have got the concept. I hope you understood all the concept whatever I explained from part 1 to part 5. So if you go from part 1 to this part 5, you will get different types of concepts over the linear means primal dual relationship concepts. So okay, all the best. Thank you, all the best.